big mistake people make will be going this way on their measurements. From this side down, or going from over here backwards. It always has to be horizontal right. It always has to be counterclockwise. You're used to dealing with degrees for angles, and degrees are a great way to measure an angle. One time around, a circle in degrees is how far? 360 degrees. In one revolution, you have 360 degrees. Well, what we found, not we, I wasn't really there, what mathematicians decided was we need to be able to take and use more accurate measurements than just degrees or decimals of degrees. So they switched degrees to degrees, minutes, and seconds. So they took 1 degree, if you could imagine this being 1 degree. It's not, but that's okay. And they went out and they said, look, if we took that 1 degree and we sliced it into 60 seconds, 60 equal pieces, we will call those, minutes. 60 equal pieces of a degree is going to be a minute. So 60 minutes will be equal to 1 degree. So 1 minute is 1/60th of 1 degree. We're talking teeny weeny. And if you took one of these minutes between these two, and you went way out where you could actually do the division, and you sliced that into 60 equal pieces, you would get 60 seconds is equal to 1 minute. So 1 degree equals 60 minutes. This is the symbol right here, 1 little apostrophe. 1 minute equals 60 seconds. So in 1 degree, you'd have 3,600 slices that are equal to seconds. There's 3,600 seconds in 1 degree. We're talking really small. And an example of what an angle in degrees, minutes, and seconds looks like is 36 degrees, 48 minutes, 12 seconds. When you're in degrees, minutes, seconds, you never have a degree, or excuse me, you never have a minute or a second over 60. You can't equal 60, because if it was 60 minutes, you would make that into 1 degree. So you always have to be between 0 and 60 on the minutes and seconds. This is not a critical component of the second quarter. It is just a unit of measure. It's like when you learn inches, and then quarter inches and half inches and eighth inches, or you learn meters and centimeters and millimeters and decimeters, that kind of stuff. That's all. It's just another unit of measure. And we'll come back and we'll look at a couple of examples here. Remember, angles start at horizontal right and go counterclockwise. Horizontal right, counterclockwise. Big angles, angles more than 360 degrees, we describe those in revolutions. How many times around did you go? Okay, you hear about, some of you techies are better at it than me, but you hear about hard disk speed at 7,200 revolutions per minute. I have that right. And you can get faster ones up to 10,000 something revolutions per minute. I don't think it's per second. And then you're just talking about the times it goes around in a minute. Here, if you go multiple revolutions, okay, you have multiple revolutions. If you're between 0 and 360, you would use degrees. And not that you can't use degrees to describe multiple revolutions. The big thing is horizontal right, counterclockwise. Those are positive measured angles. So if we are horizontal right, we start going this way, what kind of an angle are we talking? If we go down, it's got to be negative. how are we going to convert? If we have all degrees, and we want to change decimal degrees to degrees, minutes, seconds. If this is 12.31 degrees, and I want to do degrees, minutes, seconds, how many degrees is there going to be? Well, there's 12 full degrees. How do you change a 0.31 degrees into minutes? Divided by 60. Multiply. Not very confident on that one. Think about this. That's a good way to figure out whether to multiply or divide. 1 degree is equal to 60 minutes. What do we want? We want 0.31 degrees. What do you do to this equation to turn 1 degree to 0.31 degrees? If I took it to a 6th grader, what do you do to 1 to turn it to 0.31? What would you divide by? Okay, and somebody who does know, this is 6th grade, 5th grade. What do you do to the number 1 to turn it into 0.31? Times it by 0.31. So times 60 by 0.31. So you want to multiply by 60 when you're changing the degree decimal into minutes. What will that give you? Exactly. So how many minutes do we have in this decimal? 2 minutes. But we still have 0.6 of a minute. Remember, 1 minute equals 60 seconds. So 0.6 minutes, how do I turn 0.6 minutes into seconds? What do you do on the left side of the equation? Multiply by 60 again, so what are we going to get? 36. So when you're going from decimal degrees to degrees, minutes, seconds, you're timesing the decimal part by 60. If there is a decimal after the 36 seconds, 36 point something, round to the nearest second. Obviously, you don't do that here, unless they say just go degrees and minutes. You might have one of these questions on the Castro quiz. You're not going to have it. This is not critical to us. Now, how would you go the other way? How would we change degrees, minutes, seconds, 25, 26, by what? So we would take the 6 minutes, divide by 60, 6 seconds, and divide by 60, and what decimal would that give you? 0.1. So that would mean you'd have 25 degrees in 20.1 minutes. How do we change the minutes to degrees? Divide by 60 again. So the 20.1 divided by 60. Is it exact or round? So you're going to have 25.335 degrees. Now I know that I've been lenient with this, even though I've talked about it over and over again. In the 4th quarter, I will no longer be lenient. Okay? If you do not put the correct units of measure on answers, then you're going to lose a half a point or a point. And it's going to be an oversight. It's not malicious. It's not even lazy. It's just a habit. You have to label whether you're in degrees, degrees in minutes, degrees, minutes, and seconds. Because we have other units of measure besides degrees. And it is non-negotiable. So I will help you by taking points away from you. You will be upset on the first quiz if you lose 8 points because you didn't label degrees and radians. But you won't do it again. So it's going to take 8 of your points to teach you that. So be it. But I am telling you right now, you've got to make sure your labels are there. See if you can convert these two. This one to degrees, minutes, seconds. This one to decimal degrees. So A has to be 125 degrees. How many minutes? 46 minutes and 48 seconds. Anyone not clear on how to get that answer? Anyone need to see work for it? Now you also need to know how to convert back. So if you're in degrees, minutes, seconds, can you go back? You should know that it's got to be 315 points. And then what did you end up with for your decimal? 7? 592, so 59. That's degrees. You got to have a label on it. If you don't have the label, that's going to be a problem. Everybody good on those two? Does anyone need to see the work? It only takes a second. You put it up. For A. So 0.78. How do I change 0.78 degrees into minutes? What do you do? Oh. So you must have been pretty close for your answer.
When we had, like, for part B, it would have an exact, or like, so what would we round it to?
3 decimal places. Everybody good? Now, a different type of measurement is called radian measurement. Radian measurement is used, it's just different. So radian measurement we use a lot with trig. And with our trig values, you're going to find that you need to be able to do this without a calculator. You've got to be able to add, subtract fractions without a calculator. Those of you who rely on it, do yourself a favor. Don't use your calculator. When you're doing homework, don't use it. Unless it's a problem like those ones we just did. You need a calculator for that. For this stuff, stop using your calculator to do remedial math. It will help you greatly. If you don't believe me, keep using your calculator. Some of the tests in this quarter are no calculator. Some of the quizzes are no calculator. So you need to be able to do it without it. A radian measurement can be found by taking the length of the arc and dividing it by the radius. Remember, an arc length is the length or distance on the circle from point to point of an arc. An arc is part of a circle. So S stands for arc length, right here. And R stands for the length of the radius. Your radian measure, theta, is equal to S over R, which means that S is equal to theta times R, or R times theta, whichever way you want to write it. I tend to like R theta, but it doesn't matter. Theta in this picture is measured in radians. Theta is measured in radians. So when we started horizontal right and we come counterclockwise, we're measuring theta in radians of this. This is a different unit of measure. There's no symbol for radians. 1 time around a circle in degrees, how much? 3, 6, 0. How about 1 time around in radians is 2 pi. Very good. So if you've worked with radians before, the transition should be pretty easy. All the way around a circle in radians is 2 pi. The arc length, if you think about a circle with a radius 1. Okay, the arc length is going to be 2 pi for one the circumference of a circle. So 1 revolution, 1 radius times theta is equal to 2 pi. There's 2 pi radians in 1 revolution. This is just a basic algebra equation. If you look at this. 1 revolution is equal to 1 revolution, no matter how you slice it. If you do it in degrees, it's 360, and as was just pointed out, in radians, it's 2 pi. If you divide that equation by 2, you get 180 is equal to pi. 180 degrees equals pi radians. Now, I wrote that down twice because I'm going to do 2 things with it. Over here, we'll do 1, and over there, we'll do a different. If I want to know what 1 degree is equal to, how would I solve to get 1 degree here? Divide by 180. So this is going to be pi over 180. 1 degree is pi divided by 180 radians. Not a decimal, pi over 180.
So it would be,
it'll come back. If it's the red one, hang on to it. Alright? So 1 degree is pi over 180 radians.
so the measurement, we would put green, or would we have to?
Actually, you don't have to put anything. If you are talking about an angle measurement and there's nothing there, it's understood to be radians. Alright? If you don't want to risk it, put RAD or RADIANS. You don't want to use a little r, that's not an abbreviation. But for degrees, it's non-negotiable. So if 1 degree is pi over 180 radians, what do you do to 1 degree to make it into 300 degrees? So we're going to do the same thing over here. You're going to have 300 times pi over 180. Your answer is going to be in terms of pi. Do not press the pi button, and you sure as heck better not put 3.14 in for pi ever. If you use 3.14 for pi, even if the directions tell you to, go ahead and draw a red line through it and put minus 20, because you're not paying attention. Okay, and that will save you grading time. Never use 3.14 for pi. If you have to use it on an application to figure out how it applies and give a normal answer, because nobody would say, well, how far did you run today? Yeah, I ran 5 pi over 2 miles. Nobody talks like that. So change it to a decimal. All right? But in this problem, we want to know how many radians we want the exact value. 300 pi over 180. How does 300 over 180 reduce? 5 over 3 pi. So 300 degrees is 5 pi over 3 radians. That's the answer I'm looking for. If you have to use a calculator to get that, you're in trouble. Stop using the calculator. Force yourself. You need to be able to do it without a calculator. If you have 180 degrees equals pi radians, and you want to know what 1 radian is equal to, what would you divide by? Pi. So you're going to get 1 radian is going to equal 180 divided by pi. And if we want to get to 2.5 radians, what do I do to 1 radian to make it be 2.4 radians? Multiply by 2.4, so we're going to multiply 2.4 times 180 over pi. And I'll give you these conversions here in a moment. So what, 2.4 times 180? .432 over pi degrees is equal to 2.4 radians. How are we doing? Here are the conversions. So based on what we just did, if you want to go from degrees to radians, you multiply your degrees by pi over 180. If you want to go from radians to degrees, you multiply by 180 over pi. Again, not a critical component, it's just a something you should be able to do component. On a scale of 1 to 10, 10 being difficult, this is a 1, maybe even a less than 1. You just have to learn it, it's new. It's like when you wanted to go from standard units to metric units. So from degrees to radians, radians to degrees. Make sure your answers are notated correctly. If you write 28, that means 28 radians. If you write 28 with a degree symbol, that means 28 degrees. So be very specific. See if you can convert these three. Convert degrees to radians and radians to degrees. All right, for 196, what was the radian measurement? Is that exact? Okay, so who got it exact? What was it? 44 pi, I don't think so. 49.
Yeah, you're right.
49 over 45. Here's how I know that yours was wrong, and you should start to get a feel for radians. You said 44 over 45, which is a little bit less than 1, right? 1 pi is 180 degrees. This is 196, has to be more. So that's how I knew that there was an issue. How many of you fluently speak another language? Only 1? 2? This is when I ask a question, raise your hand like this. Going like this doesn't help me. So you speak another language fluently. Did you learn your other language first or second with English? So you learned English first. English first? Okay. So can all 4 of you think in your other language? You for sure, I would assume can. I speak French. I can read French, I can speak it, although it has waned terribly since my grandparents passed. When my grandparents were alive, my grandmother, I found out, was a big fat faker. Well, she was little, but she used to tell me, she would talk to me, and she would write to me in English. You know what I would get? I would get, "Dear David, how are you? We are fine. The weather is good. Hope you are well. Love, Grandma Angie." It took me a long time to realize my grandmother can't do anything in English. If I talk to her in French, we're all good. I can find out everything that's going on, more than I ever wanted. So I told her that she needs to write to me in French. Everything after that was great. This was back in the day when writing on paper occurred. I know, ancient history. Okay? I was good enough to be able to read French, and I was good enough to be able to converse in it so that I could communicate. My mother is fluent, I am not. I cannot think in French, and now I suck at it. But I was always translating back and forth in my mind, English, French, English, French, English, French. Whereas if you can think in your language, you don't do that. And that's where my weakness was. You have to start to learn to think over the next couple weeks in radians, not in degrees, and not converting back and forth. There are no exceptions to this statement. Kids who convert back and forth don't do as well as the kids who learn how to think in radians. That's bottom line fact. I'm telling you right now. So as we progress through in the next couple of weeks, that's our foundation for radians. Take the time and do the extra effort so you understand what it means to be in radians. Right? 1.35 radians, how many degrees?
243 over pi.
243 over pi degrees. You don't really need the symbol because you have the word. Everybody get that? How about the 2.5 pi radians? 450. Exactly. On any of those three, do you need to see the math? Anyone need to see the math on the conversion? This website is pretty good as a reference. You'll get references from me. You'll get worksheets or reference sheets. Some of them I just steal. Some of them I make. Some of them I do both. I steal what I like and then I make it into something for you. Mathpage.com and then the trig section. I don't know if you need these slashes, but you'll see that page has a bunch of stuff on it. It is worth visiting. I think that you'll find throughout the next 10 weeks that you might find some resources there. Some of you need them, some of you don't. But they just provide you with different explanations, different practice, different study things, all good. This is a pretty good site. Now I'll give you a couple more over the next few weeks. But the mathpage.com and the trig stuff that they have there is pretty good. This will be online. It's also on YouTube. The notes will we'll videotape almost everything here on out. So you'll be able to hear, if you're absent, you can go and watch the lessons, get the notes online, and get yourself caught up, and then come in and ask for help. You got to do that. Okay, you got to be responsible if you're absent. Anybody who wants it got it? Do we need more time on this? All right, this page has a lot of information on it. We'll go through it pretty slowly. And you're starting to see how we visualize things here. Horizontal axis, vertical axis. Horizontal axis, horizontal right with a circle here. This is where we measure angles from horizontal right counterclockwise. Going around the circle, when you get to the y-axis, you're at 90 degrees. Back to the x-axis, you're at 180. Back down to the y, you're at 270. And back up to the x, you're at 363. One complete revolution. We always go counterclockwise. When you have an angle, like the ones I just mentioned, whose terminal side of the angle is on the x or the y-axis, regardless of the direction you turn, if you start at horizontal right, you are looking at what we call a quadrantal angle. Quadrantal angles have a terminal side on the x or y-axis. In degrees, you're looking at 0, 90, 180, 270, and 360. In radians, you're looking at pi over 2, pi, 3 pi over 2, and 2 pi. Those quadrantal angles you need to memorize. They're going to be very important for us when we get to trig ratios. They're also the easiest trig ratios to know. So make sure you know every 90 degrees and every pi over 2 radians, you're at a quadrantal angle. Pi over 2, pi, 3 pi over 2, and 2 pi. And if you went negative pi over 2, negative pi, negative 3 pi over 2. Same thing. The second thing on this page is that coterminal angles have the same terminal side. That just means the angle ends in the same spot. So if you think about revolving yourself around a circle, and we start here at horizontal right on the circle, and we go in this direction, I'm ending here on the second revolution. That's coterminal with my first time I end here on the first revolution. 90 degrees plus 360 more is 450 degrees. Those angles are coterminal. If you start here at horizontal right and go backwards until you hit that same location, that would be negative 270 degrees, as shown in red. The 90 is in green, the blue represents 450, and the red represents a negative 270. All three of them are in the same spot, so they're called coterminal. So in order to find coterminal angles in degrees, you're going to keep adding 360. So your formula is theta plus 360 times n. And n can be any integer. As long as n is an integer, 360 theta plus 360n will give you coterminal angles. Put a 1, put a 2, put a 3, put a negative 1, 2, negative 3, put a 0. Put 0, you're going to get theta. If you do this in radians, you're going to add 1 revolution, which is 2 pi times n again. So theta plus 2 pi n, where n is an integer. If you need an example with radians, I did one off to the right here. If you took pi over 2 radians, which would be right here, and you add 1 revolution, 2 pi, you get common denominators, gives you 5 pi over 2. So you have 5 pi over 2 radians. That's coterminal with pi over 2. If you add 2 pi to 5 pi over 2, you get 9 pi over 2. If you take pi over 2 and subtract 2 pi, you get negative 3 pi over 2. Again, you need to be able to do it without a calculator. Do yourself a favor, don't practice with the calculator. Now, I'm not trying to get you to multiply those decimal conversions to degrees, minutes, and seconds. That's what I'm talking about. This is basic. Don't use a calculator. You'll help your cause. You have to trust me on this. I am watching out for you, for your best interest in the second quarter, fourth quarter, the second half of this class. If your mindset right now is I just have to make it to Friday, it'll be good. You need to check that for this class. You can do that in English and history and science, who cares? In this class, you're taking your complete foundation for the second quarter and saying, oh, I'll worry about it over vacation, which is a big fat lie. Okay? You guys, some of you are going to leave on Wednesday because you're going to Mazatlan or whatever. Going to Tahiti, we can just pick 9 days, we need all of it. So you're not doing any math, I get it. But for these 5 days, you need to really dig in.
What's the purpose of using fractions?
What do you want to use?
Oh, I'm saying you can put it in decimal form, so what's the, like, why is it a fraction?
What are you going to do for pi over 3? What are you going to do for 5 pi over 3, and 2 pi over 3, and 7 pi over 6? Everybody uses these exact value fractions, so you don't have to worry about the decimals. and if you want to memorize decimals, you can absolutely do that. But I'm just telling you this is the way that you want to do it because it's easier.
Wait, which ones are the quadrantal angles?
What does it say?
The terminal side of X and Y axis.
So any angle that ends on the x-axis, like this angle right here, right? Is that anything on the x or y axis? Here's where I ended, right here. Is that point on the x or y axis? Really, which axis? It's what? It's not. What about this point? What about this point? How about this one? Which axis? So this angle, 90 degrees, is a quadrantal angle. Does that make sense? Because you're rotating through. When you get here, I call them the corners. I know it doesn't make sense to call something on a circle at the corner, but I'm thinking, right here. So on the corners, y-axis, x-axis, y-axis, x-axis. Anything on those spots, that's going to be quadrantal. And those things are huge for us. They're 90, 180, 270, and 360, and 0. Going with the radians, it's pi over 2, pi, 3 pi over 2, and 2 pi. Does that make sense? So you've got to end on one of those axes, either direction. Somebody else? This is really important. There's a lot of information here. Not hard information, just a lot of information. All right, so these angles, any angle that ends on this yellow arc is where? Where are angles on that yellow arc? What's that? That's true. Where are they? Not what are their measures. First quadrant. Okay? When we first learned about a plane and we divided it with a coordinate system, x-axis, y-axis, we identified 4 quadrants in which points could be located. Our favorite quadrant turns out to be quadrant 1. Why is that? Everybody's positive. It's just so much easier to work there. That's where applications occur, quadrant 1. Right? That's where applications occur. When you're an angle in quadrant 1, we're going to refer to them as reference angles. You'll hear me call them reference alphas or reference thetas. But in quadrant 1, you're talking about a reference angle. There are 3 other angles in the first revolution that are related to that reference angle. And they are in each of the other quadrants. Now, why they're so related, we'll get to as we progress through. I just need you to know that there are 3 other angles related to your theta in quadrant 1. Doesn't matter what the measurement of theta is. But if you can imagine this angle right here, I don't know what its measure is, but I'm calling it theta. This arc right here. So this angle right here, from horizontal right up to this point. If I transpose that angle going from horizontal left backwards, so this purple angle right here is equivalent measurement with a protractor for theta. And I want to find out the measure of the actual angle with this side, this purple angle right here. That would be 180 degrees minus whatever the value for theta is. So if I want to know what this angle is in quadrant 2, it's going to be 180, go all the way over to here, and back up however much theta was. So that would give you 180 minus theta, or in radians, pi minus theta. And those 2 angles, theta and 180 minus theta, will be related. For example, if theta was 40 degrees, the angle in quadrant 2 would be 180 minus 40, or 140 degrees. So if we said this is 40 degrees, this is going to be 140 degrees here. Does everybody follow that? How to get it in quadrant 2? You want to have these memorized. These don't go away. How do you get an angle in quadrant 2 if you know the reference theta? 180 minus theta pi minus theta. Right? How are they related? Doesn't matter right now. Doesn't matter. We don't want to pile too much on. In order to get to the angle in quadrant 3, if you can visualize putting angle theta right here, so that this arc and this arc, same angle measurement. If we're doing the red, we would come this far, which is all, well, I've gone 180, plus theta. So 180 plus theta in degrees, or we come around to pi, and then add theta in radians, pi plus theta. And then in quadrant 4, the green, in order to do the green, what you want to do, looking at this angle right here, in order to measure this green angle, you would go all the way around 2 pi, or 360, and then back up in quadrant 4. So 360 minus theta, or 2 pi minus theta in radians. Now, there's always 1 or 2 people who do not heed the next statement. There's always 1 or 2. You always find your angles in quadrants 2, 3, and 4 by adding or subtracting from the horizontal. So it's 180, the horizontal, minus theta into quadrant 2, 180 plus theta in quadrant 3, and 360 minus theta in quadrant 4. You never go off the vertical. You never do 90 plus something or 270 plus or minus something. If you find yourself doing that, it's wrong. There's one exception where it will work either way. What angle will work? What theta value will be correct, even if you went off the horizontal? 45. That's the same as saying the statement about a broken clock. What's the statement? It's right twice a day. A broken clock, it's right twice a day. Doing it wrong works, but only when theta is 45. Don't ever go off the vertical. These are always off the horizontal. Now, I know that that's not going to help two of you in here. You have to make the mistakes, and you will, but you need to do it off the horizontal. Any questions on the reference alphas are in quadrant 1 or reference thetas? How do we get to quadrant 2, 3, and 4? Everybody good? These are the 2, 4, 5 things that you want to have a good understanding of based on what we've said so far. Okay, we've already defined all of these. Are there any of them that you're not clear on? Take a look and see if any of these things don't make sense to you. But you can't remember in your notes, do you have this? Standard position is horizontal right, counterclockwise. So when we measure an angle, we always, standard position is start with horizontal right here, and make sure that you're going in a counterclockwise direction. That's what we mean by standard. Anyone not clear on any of the other 4? Great review time. Good? You're going to start to see this wheel with these, the 12 spokes in the 4 quadrants, not counting the X and Y axis spokes. You don't need to worry so much about the numbers on the outside. right now. In fact, you don't need to worry about them at all. If you want to get a copy of this printed offline, you can add in the radian angle measurements later. It's not that important. I'm going to give these measurements to you in a few minutes. What's important is what we referred to earlier in quadrant 1. Why do we love quadrant 1? Because it's positive, positive. In quadrant 2, you're negative, positive. In quadrant 3, you're negative, negative. In quadrant 4, you're positive, negative. You need to make sure you have those down. Right? So plus, plus, minus, plus, minus, minus, plus, minus. Don't worry about the radian part right now. They're going to ask you questions like this in your homework. Maybe on a quiz you might get a part of a question like this. Find two angles, a positive one and a negative one, that are coterminal with pi over 4. Are we in degrees or radians? How do you know? That's the wrong answer. There's no degrees. Be careful, you will get tricked with that. Right? If you see 2 pi with a degree symbol on it, then they're talking about 6.28 blah 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 degrees. If there's no degree symbol, that's how we know that they're radians. Don't fall for that trick. Okay? It's not a very nice thing to do to you, but I'm giving you a heads up. They will do it occasionally. Same thing if you see 45 and you say, oh, that's degrees. It's not. There's no degree symbol. That's 45 radians. That means you went around a bunch of times and then you stopped. Okay? So be careful with that. This is in radians. How do we get a coterminal angle with pi over 4? Add 2 pi, or add 4 pi, or add 6 pi, or 8 pi. I added 2 pi and got 9 pi over 4. To get a negative angle, you subtract 2 pi. Remember, it's theta plus 2 pi n. And this negative will be subtracted. Now you can be creative, or you can just do the first one that comes after pi over 4 is 9 pi over 4. The first one going backwards is negative 7 pi over 4. Those are all identified in blue, green, and red right here. Here's theta in red. Here is 9 pi over 4. One time around, plus another pi over 4. And then going backwards, 3 pi over 4 gets you in the same spot. You are going to want to make sure you're crystal clear on being able to find both. Again, it's just a matter of getting used to dealing with the radians. I would encourage you, I know most of you guys are really good with your notes, and I should have said this at the get-go. I would encourage you to start paying attention to the notes in terms of, this is section 7.1. This is the first section. You don't have to maybe put the date in there. A lot of times you're going to reference back to a section. If you don't separate your notes, you might have a hard time figuring out where everything is. Don't do homework with your notes. Do them someplace else so that all your notes are consecutive. So this one's with degrees. How do we find the angles in degrees? One positive, one negative coterminal. Plus and minus 360. So 225 is where you start, add 360, 585. Subtract 360 from 225, it's negative 135. If you need another one, you can subtract another 360 and add another 360. Don't tell me 225 is coterminal with 225. Yes, it is. It's the same angle. Of course it's coterminal. These are your families that you're going to need to know. There's 4 of them that I'm going to give you. And you're going to ultimately have a lot of memorization to do with these. However, I will show you ways to remember not only these and the other ones, the other families. I'll show you shortcuts when you get right down to it. Right now, I'm just going to give you the families. You don't need to go home and memorize these tonight. These angles are your quadrantal angles. So in degrees on the left and in radians on the right. These are the angles you want to be most intimately familiar with. 0, 90, 180, 270, and 360. And then with these five angles, these five quadrantal angles, there are three other families that we work with in here. If you go to calculus, and if you go on and take calculus in college, they're going to add probably two more families to this. But we're only going to do three. The first one is the 30-degree family, or the pi over 6 family. So in degrees, quadrant 1, 30 and pi over 6 are the same angle measurement. The quadrant 2 angle, quadrant 3 angle, and quadrant 4 angles in degrees and radians. Please don't go and memorize these tonight. Again, I'll give you a better way to do that when the time is appropriate. I just want to give them to you right now so you have them. So the 30 degrees has three other angles related to it, 150, 210, and 330. You should remember how we got them. 30 is your reference alpha. 180 minus 30 is 150. 180 plus 30 is 210. And 360 minus 30 is 330. And the same is true for radians. Pi over 6 is your reference alpha. Pi minus pi over 6 is 5 pi over 6. Pi plus pi over 6, 7 pi over 6. And 2 pi minus pi over 6 is 11 pi over 6. You need to be able to get from quadrant 1 to quadrants 2, 3, and 4 very quickly, regardless of whether they're a family or not. If I give you an angle 2 pi over 13, you better be able to find the other three angles. Quadrants 2, 3, and 4 using those formulas. Everybody got these? Okay. The second family, 45 degrees, or pi over 4 if you're in radians. Again, the most important angle is the family name, the 45 and the pi over 4. If you know those, I'll show you how to find the other ones. It's pretty easy. So we got 30, we got 45. Who's next? 60. Again, don't go and work on memorizing these. It's not important that you do that. If it was, I would tell you. I'm not trying to put you off. If you know the families and you want to memorize that it's 30 and 60 and 45, that's great. If you want to memorize the radians, it's pi over 6, pi over 4, pi over 3, fantastic. Learn the quadrantal angles, both in radians and degrees. Make sure you can convert from degrees to radians, radians to degrees. A minimum concept would be converting your degrees, minutes, seconds, and decimal degrees back and forth. But again, it's not a huge issue, just you don't want to give it away. You should be able to do that. This is where your homework is. Try not using a calculator as much as possible.